Hi everyone, this is Mrs. Eggerding. Since we have a late start on Tuesday, we are giving you a little part of the lesson here on this video and hope you will use it to help complete your assignment. So this is for Mr. Kushnitsky and Mrs. Eggerding's class. We're going to talk about writing polynomials. And there's two types of questions that they could give you. This first one, they ask you to find a polynomial of degree 3 with real coefficients that satisfies the given conditions. And for this one, I listed 3 zeros of 2, -3, and 5, and then a value of f of 3 equals 6. Okay, so we're going to use this last part, the f of 3 equals 6. We'll use that a little bit later. First, with the zeros, we are going to reverse factoring. So if I have a 0, let's change colors here. Oh, I think blue, navy might work a little bit nicer. So if I have a 0 of 2, that means x equals 2. What that does is it gets me a factor of x minus 2. In a similar fashion, from the x equals -3, I get a factor of x plus 3, and then the 5 gets me a factor of x minus 5. Okay, so here is the beginning part of our polynomial. Now I can start distributing this, and if I take the first two, I get x squared plus x minus 6 times the x minus 5. And if I distribute this, I get x cubed minus 5x squared plus x squared minus 5x minus 6x plus 30. And so combine like terms, you get x to the third minus 5x, whoops. Combine like terms, that becomes 4x squared minus 11x plus 30 equals this function. The last thing that we need to check is this condition true? In other words, when my x equals 3, does this y coordinate equal 6? And that may or may not be true right here at this moment. And so we have this factor of a hanging around the front that can help us out. And so if I check this really fast, let me see, if I plug in 3 here, this becomes 27 minus 3 squared is 9, 36 minus 33 plus 30. I want to know, does that equal 6? Okay, and I'm going to slide this on over here so we have a little bit more room. 27 minus 36 is -9, minus 33 is -42, plus 30 is -12. So since that doesn't equal 6, I must have this a value of -1/2. And so that -1/2 needs to go in front of my function. And so now I have written a function with real coefficients that satisfies those given conditions. So you start with taking the zeros, and you write the zeros as factors. Once you write those as factors, then you look for this a value out in front to ensure that you meet the condition of f of 3 equaling 6. So the second type of function, or second type of problem, they'll say find a polynomial function of least degree having only real coefficients, and then they'll give you zeros. They won't give you a specific point, which means we don't have to worry about that a value controlling a specific point. Couple things going on here. First of all, least degree, which means you don't have to worry about multiplicity unless they ask about it. Second thing is this idea of having only real coefficients. With this requirement, what this is telling me is it's telling me the imaginary roots are traveling in those conjugate pairs. Okay? So on this problem, even though they only gave me 2 plus I, because of this condition about real coefficients, if 2 plus I is in there, I have to use 2 minus I also. And then they tell you the negative 3 has multiplicity too. Going to approach this the same way. So this function is going to be written as factors. The negative 3 gets me x plus 3. It has multiplicity 2, so I'm going to write it squared. Then I'm going to write my imaginaries. So x minus 2 minus I and x minus 2 plus I. So here is my factored form of this polynomial. But again, they are asking me to do real coefficients, so I am going to multiply things out. The first one is the square of a binomial, so I can do that. This second one, make sure you always do the i's at the same time because things will cancel out nicely then. So you get the x squared minus 2x plus ix minus 2x plus 4 minus 2I minus ix plus 2I minus I squared. So first polynomial stays the same. Start combining my like terms. I get x squared, negative 2x, and negative 2x is minus 4x, plus ix minus ix, minus 2I plus 2I, negative I squared becomes plus 1, and with the plus 4, that becomes plus 5. Now I have some real coefficients. I can start distributing these two, and it's x to the 4th minus 4x to the 3rd, 5x squared, 6x to the 3rd, 24x squared, 30x, 9x squared, 36x, ran out of room for the plus 45. Combine all those like terms. X to the 4th plus 2x. I'm having issues with the pen. Those are gone. Let me see. 5x squared, 9x squared is 14, minus 24 is negative 10x squared. 30 minus 36 is negative 6x plus 45. So here is my polynomial in standard form. The smallest degree is going to be 4 with these roots. The big thing here is when you see the phrase real coefficients, make sure you get those imaginary roots in those conjugate pairs and take care of that multiplicity. So the assignment you should be finishing up is page 338. It is 35 to 71 odd. They start with, can you find zeros and factor, and then it ends with these multiplying ones. Feel free to post any questions you have on Schoology, help each other out, and we will see you on Wednesday. Thanks. Bye-bye.